Intensity pattern of capital N slits, part B. To carry out the sum in part A, it's convenient to use the complex number relationship e to the iz is cosine z plus I sine z, where I is square root of -1, imaginary number. In this expression, cosine z is the real part of the number e to the iz and sine z its imaginary part. Show that the electric field EP at point P as a function of time is equal to the real part of the complex quantity sum n equals 0 to capital N minus 1 E0 e to the I kr minus omega t plus n phi. Okay. So this is going to be easy. We have e to the I kr minus omega t plus n phi according to this expansion can be written as cosine kr minus omega t plus n phi, the real part, plus the imaginary part, I sine kr minus omega t plus n phi. This is because we can write e to the iz as cosine z plus I sine z, real part plus I times the imaginary part. Now, what is the real part? The real part will be e to the I kr minus omega t plus n phi. Real part is basically cosine kr minus omega t plus n phi. And imaginary part of e to the I kr minus omega t plus n phi will be sine kr minus omega t plus n phi. Okay, so we can basically see that the real part of the summation n equals 0 to capital N minus 1 E0 e to the I kr minus omega t plus n phi. For each term here we have the same relationship, is basically sum n equals 0 to capital N minus 1 E0 cosine kr minus omega t plus n phi. And this is basically what we have shown in part A of the problem. The electric field at point P is the sum, and that sum n equals 0 to n minus 1 E0 cosine kr minus omega t plus n phi is nothing but the real part of the sum n equals 0 to capital N minus 1 E0 e to the I kr minus omega t plus n phi. And so in part B of the problem, we were supposed to show that the electric field is the real part of this quantity. So that's exactly what we have obtained for the electric field at point P. So this is the electric field at point